Okay, I want us to do the correction. If you remember the short test we did the other time, I want us to do the correction today. We are given a haloalkane which contains an iodine. We have reaction 1, reaction 2, reaction 2, and reaction 1. Then we have a compound C and D. And this will be similar to what we expected to see in examination. And the very first one, we are asked to classify the haloalkane given to us. And we know the first one is primary. And remember, when we say something is primary, permit me to do some clarification here. We have the halogens, and anytime you are putting in the hydrogen, please do that diligently and make sure you didn't omit anyone, because once you are omitting any hydrogen atoms, it means you'll be losing that mark. Be careful with that. Make sure you didn't lose any hydrogen marks. So if you look at it here, we see this is our functional group, and you will see it is attached to one carbon directly. There is no other. The carbon that is having the functional group, the carbon that is having the functional group is attached to one other carbon. This side is hydrogen and the other side is hydrogen. So, and that's why we said that it is a primary. So we are saying that the carbon that is having the functional group is attached to one other carbon directly. So here is hydrogen, the other one is hydrogen. So it is a primary haloalkane. And we said that the reason being that the carbon bearing the functional group is attached to one carbon atom directly, and that's why we say it is primary. And the next question is we are required to state the structural formula of C. And one important thing I would like to stress here is this. 1, 2. I will first of all make a clarification. Then after that clarification, I will answer the questions. Anytime you are given a haloalkane, this is a common question. I keep saying that if you are given, if the reaction conditions, if we have a dilute, if we are using a dilute sodium hydroxide, potassium hydroxide, lithium hydroxide, whichever one, and we are using a mild heat, there are two possibilities. Or we might be using concentrated sodium hydroxide or potassium hydroxide or lithium hydroxide, and you are heating strongly. These two reactions, you must take note of that. Once we are given the dilute one, then you know that the reaction that will be taking place will be substitution. But if you are given a conc sodium hydroxide, then the reaction that will take place will be elimination. Take note of that. The examiners like to repeat it over and over and over. And remember that this is the one we call hydrolysis. Take note of these two reactions. It's confusing, but it's not confusing. And examiners, they like to repeat all the time. Dilute substitution, which is hydrolysis. If it is concentrated, you are heating strongly, it's an elimination reaction. And anytime we have an elimination reaction, remember one of the products will be an alkene. To take note of that, then now I will go straight to the answer. I will not go and answer our question, but I feel I have to make this clarification first before we go to any other one. So here we are given 2, 3, 4. you have hydrogens attached. So here we are using a dilute sodium hydroxide, and we are applying heat, but we are heating gently. So in this very case, you see the reaction will take place here will be hydrolysis, which will just be the exchange of ions, this functional group. So OH will be here. So you see what will happen between this one and this. They will just change their position. It's as simple as that. So in other words, what I'm going to have here is 1, 2, 3, 4. Remember, we are asked to draw the structural formula. Don't make the mistake of writing this. Show all the bonds. Don't write OH, hydroxy group. Show all the bonds. It's a common mistake. I've seen it many times. Show all the bonds that are present, because you're asked to draw the structural formula. So immediately you look at it, you see we are getting butan 1 or 1 butanol, whichever one you prefer. And you now see that in addition to that, although this question does not ask this, you will see you have sodium iodide. So this is our C. You label it clearly because this is what the question wants. This is our C, butan 1 or. Okay, now let's go to 1,3. And if you look at it there, you will see that each of the reaction we are given the first one, reaction 1. You will see that this reaction 1 will be addition. And remember, addition, you should not mix it up. Anytime you have a multiple bond, anytime you have, this is unsaturated. This is an unsaturated. Alkene is an unsaturated compound. Anytime you have unsaturated compound giving you another thing, in other words, we are adding a molecule there, it becomes addition reaction. So in this very case, you can see that because this one have an OH ion, you will see we are adding water, which we call hydration. So the name of the reaction is hydration because we are adding water, but the type is addition reaction. Then the second one I've talked about it. Substitution, hydrolysis. Remember, in the case of this one is hydrolysis. It's straightforward. I've emphasized it before. Then the last one is we have number 3. You can see this going to this, and once the unsaturated compound is the product, you will know it's elimination. But if unsaturated compound is a reactant, you know it will be an addition. So here you can see we have elimination reaction. And in this very case, you will see we're eliminating dehydrohalogenation. We are eliminating hydrogen halides. So we have dehydrohalogenation. And 1.4, if you look at 1.4, which is, we are talking about this reaction from alkene to alcohol. So you can see that alcohol have OH. So you should know that we are getting that OH from water. And in order to get that reaction, remember the catalyst we usually use concentrated. Please write it in full. Concentrated phosphoric acid, which is H3PO4. Also be very careful and know whether are they asking about the formula or the name. Don't assume. Read the question very well and find out, did they ask us to write the name? Also, common mistake, please write this thing in full. Write this in full to be assured you are getting all the marks involved. Phosphoric acid. You can also use sulfuric acid, which is H2SO4. But I prefer using phosphoric acid, H3PO4. And remember this reaction is, as we said, is hydration, the addition of water. Then the last one is an esterification reaction. We've talked about it before. This one is an esterification reaction where you have C turning to D and we are adding this. So 1,5 is an esterification. Esterification reaction should be a giveaway. Practice this all the time. There is no way you can write an examination, matric examination, without esterification. So here you have an alcohol. Remember, we have 4 carbon here, so we're dealing with butanol there. And so we have butanol, 1, 2, 3, 4. Remember, we are asked to write the structural formulas. So because of that, I will going to show all the bonds. I will not miss anyone, and I will be focused to make sure I didn't miss any hydrogen. So if you look at it here, all the hydrogens and the bonds are shown. Plus, I'm adding ethanoic acid. Ethanoic acid. 1, 2. Ethanoic acid. So if you look at it here, you will see that the basic things will happen there will just be elimination of water. So here I will have this. We are using concentrated sulfuric acid. We are using this as a catalyst. We are also using this as a dehydrating agent. It will remove the element of water. So in other words, it will remove OH from the alcohol. It will remove the hydroxy group. Remember the name, hydroxy group. Then it will remove the hydrogen from the carboxylic acid. Remember, it's not the other way around. The hydroxy group will be removed from the alcohol. Then the hydrogen will be removed from the carboxylic acid. So if we do that, you will see the first thing that will be formed will be water. You will see that the water will be formed. So in addition to water, you will now see that you have this. Why having this one linking to this? Just this. I'll take it here, I link it here. I'm just copying and pasting. There's nothing difficult there. That's what I'm doing. So I write this one first. 1, 2. You can see what I have originally: hydrogen, hydrogen, hydrogen. Then the next one is the whole of this. 1, 2, 3, 4. And make sure I put all the hydrogens. That are involved. So if you look at it here, this is hydrogen there. So if you look at it here, I have 1, 2, 3, 4. I have butyl 2 here, ethanoid. So what will be formed will be butyl ethanoid. So if you're asked to draw the structural formula, let's not forget, let's show all the bonds that are present. Because if you master this, you will see that in the case of organic reaction, is one of those easy topic to master in examination. Believe me when I say that. Apart from question 1, this is a general question. Question 2, usually intermolecular forces. Another one is this organic reactions. So go over it over and over and over again. It's easy to total all the questions here because all the questions, all the reactions have been given to you already. Remember what I said, anything from unsaturated is going to saturated, so it will be addition. But if you are forming an unsaturated compound, it should be elimination. So you should know that something has been eliminated.